All right, so why don't we go ahead and get started? I want to welcome everyone to today's webinar, Artificial Intelligence and Machine Learning, Turn Your Data into Actionable Insights. As you can see, we have a really full program. My name is Claudia Ellison. I'm Director of Programs here at eHealth Initiative. But before we get started, just a few housekeeping items. All the participants are muted. You'll probably see on your screen there are two boxes. One is a Q&A box and one is a chat box. So if you're having any technical difficulties, please use the chat. Our team member Ali will respond to you. For Q&A, please use the box that says Q&A, and this helps. The questions are recorded, and then if we don't have time, we can get back to you after the webinar. So just a little bit about eHealth Initiative. We serve as the industry leader in convening executives to identify best practices to transform healthcare through the use of technology and innovation. We've got several current areas of focus, being value-based care, interoperability, privacy and security, analytics, and social determinants of health. And all the work that we do with our task force meetings and webinars, et cetera, are put onto our eHealth Resource Center. So when you get a chance, please take a look. And we always look for really good information outside of the work that we do. So if you have items that you'd like to contribute, please don't hesitate to go on and submit your work. So we're really thrilled that we're able to work and accomplish the work that we do with so many different types of HIT stakeholders, with payers and providers and other stakeholders. We reach out to these organizations and companies for webinar speakers and roundtables, et cetera. And we've got an amazing group for our board and our leadership. As you can see, we've got just a wonderfully diverse group of members from Cerner, from provider organizations, payer organizations, et cetera. And we also have several events that we do, and I hope that if you are at HIMSS, that you will join us at our reception, which takes place on Tuesday, March the 10th. Please join us, and we'd love to be able to meet people that we haven't been able to meet in person or meet new people. And of course, the work that we do is we're able to do only with the support and generosity of organizations and companies such as Cerner. So on that note, I'm going to turn this over to Cole Erdmann, who's the Director of Clinical Intelligence from Cerner.
Yeah, thank you, Claudia, and thank you everyone for joining. Today, we have some really nice presenters here, and luckily I've had the opportunity to work with them and collaborate with them over the last several years, and the presentations they're going to highlight really help go through the opportunities in healthcare and what the promises of big data bring to us. And our first presenter that will go up will be Navneet. Then we also have Dr. Feaster and Janos Hajagos. And there's some really nice things that they're going to go through and present, and I hope you enjoy the session. But before we get kicked off, we just want to give a little background and a little context around the solution that the teams have been using to support their data science initiative. And then if you could go to the next slide. The solution we've been working on has really been came out of the concepts of some of the core challenges that we all face inside healthcare, using data, managing data, and making things, creating insights out of that. And the first is really just the complexity around healthcare data, managing multiple sources, aggregating things, and using data becomes a challenge. And so what we've been focused on for the last 6 years or so is getting our data sets organized and structured in a common data model, applying industry standard ontologies and nomenclatures on top of that data structure to make it usable for a data scientist. And then getting our data so we can create a higher level abstraction for data scientists for quick starts and reusability of their code. And quickly what you find out inside healthcare is the volumes are just massive. And the infrastructures, when they're disparate or operating in different areas, really can become difficult from a data science perspective. And so our partnership with AWS is critical to getting to the scale and management of our data inside healthcare, which is expressly complicated and large at times. And then all those things have really just led to the limited adoption of AI and ML inside healthcare, and our ability to take those insights on the same data, this really complex, rich data sets, and then deploy those insights is really the final leg of the journey. And if you could go to the next slide, please. And that is really the closed loop cycle in which we've been developing towards and working with our teams around creating a secure and safe environment with all the data for the data scientists to manage, applying common industry tool sets and toolkit on top of that data, allowing for the use cases of validation, iteration, simulation, and creation, and then deploying those directly back to the workflows. So the insights from that data scientist and all the research that has been done can be realized inside the clinical practice. And that's where we'll see the change in the evolution. And with that, I want to pass off the mic to Navneet, and he'll go through some of our infrastructure aspects.
Hi, thanks, Cole. That was a great introduction of the work that we do, with Cerner on Hello. My name is
Navneet, we're having a hard time hearing you.
Cole and his creating data scientists create machine model. Can you hear me? Is it
A little bit. And now we don't hear you. Yeah, definitely some technical difficulties here with the sound.
Can you hear me now? Is it better?
Yes, much better. Thank you.
Oh, sorry about that. So hello, everyone. I'm going to go start again. Thank you, Cole, for giving that introduction. And we're very excited to be working alongside Cole and his team on creating and deploying Healthe DataLab application, which enables data scientists all across to create machine learning model with ease. So what I'm going to do today, I'm going to just walk over a bit on some of the core foundational elements of Healthe DataLab and how AWS is supporting. So the very first thing is that, so Healthe DataLab solution is born on AWS, and it utilizes our object storage, data pipeline components, and Amazon EMR or Elastic MapReduce, among other solutions. Its ingestion platform brings data from various sources and lands in a data lake architecture S3. The concepts behind a data lake seem simple. Securely store all of your data in a raw format and apply a schema on read, a metadata. The data lake solution on AWS has been designed to solve ingestion and metadata challenges by managing metadata alongside the data. You can use this to provide a rich description of the data you are storing. Data lake stores raw data, among other things. So the quality of the data you store will not always be perfect, and you take steps to improve the quality through transformations and all. Next slide, please. So as I said, some of the core components of a data lake architecture is defining your user access, who has rights to access your data, how are they accessing your data, through roles, through open IDs, and there's so many different ways you can specify. But of course, security of the data is the top priority. Once you land your data in a data lake in S3, like in Healthe DataLab architecture, you define a set of metadata through Hive Metastore or RDS or Blue-like concepts, wherein you define how this data needs to be accessed, as well as how the data structure looks like. Data movement, once Healthe DataLab brings data into a data lake, it moves around, has certain transformation routine built into that, and AWS with its set of services which is leveraged by the platform to have that kind of transformation in place. And finally, analytics and machine learning, component of our data lake that enables you to write machine learning models, data analysis, dashboarding, KPIs, you name it. Next slide, please. So one of the framework of that is widely adopted and used on top of a data lake is that of Apache Hadoop. Apache Hadoop is an open source software project that can be used to efficiently process large data sets. So instead of using one large computer to process and store the data, Hadoop allows clustering commodity hardware together to analyze massive data sets in parallel. There are many application and execution engines in the Hadoop ecosystem that provides a variety of tools to match. And Amazon EMR or Elastic MapReduce makes it easy to create and manage fully configured Elastic clusters of Amazon EC2 instances running Hadoop and other applications in the ecosystem. So I'm trying to connect the dot. You bring the data from the source system, you bring it in a data lake, you apply all sorts of security. Now you're ready to perform data analysis, cohort building, and all that stuff, and how you can use different frameworks like that Hadoop that can help you kind of leverage the scale and different data science principles. Next slide, please. And one such module or one such framework which is used by Healthe DataLab is called SPARK. So Apache SPARK is an open source distributed processing system commonly used for big data workloads, similar to Hadoop, but Apache SPARK utilizes in-memory caching and optimized execution for fast performance, and it supports general batch processing, streaming analytics, machine learning, graph database, and ad hoc queries. Very similar to the use cases and the challenges that Healthe DataLab is trying to solve for the community. Apache SPARK is natively supported in Amazon EMR, and you can quickly and easily create Spark clusters from AWS management consoles and all. Next slide, please. So how this all get connected together, and that's the kind of work that Healthe DataLab team put together using AWS managed services. So data comes from various sources, including that of population health system, into an S3 bucket, kind of the data lake that I was explaining before. Once the data lands in there, we go through a data pipeline or orchestration routine to transform data. Some of the data stays in the raw format, depending on the machine learning model that you're trying to write. Let's say, for example, if you have an unstructured database models or a medical images based model, you would leave them as is. But if you want to have more structured data, then you would be applying those transformation. That work is done using data pipeline. And then to create the metadata architecture that we saw on the data lake slide before, Healthe DataLab team utilizes Amazon RDS, which is our database management service managed by Amazon. So data comes in, sits in the S3 lake, goes through some transformation, metadata gets created in RDS. And then what we do is we provide a Jupyter notebook to an EC2 instance. So the data scientist, the user of Healthe DataLab, would log into this notebook, and they would be accessing the metadata and the source data, which is sitting in S3 and RDS. Underneath, Healthe DataLab uses Amazon EMR, the Apache SPARK framework that I was talking about before. And basically, Amazon EMR is also sitting on top of the same data lake and utilizes same RDS metadata. So as a data scientist, I would be logging into the Jupyter notebook, and that Jupyter notebook gives me full access to the underlying data. And whenever I want to build cohort, run queries, write my models, that Jupyter notebook then gets connected to the Amazon EMR that kind of scales out your number of instances based on the machine learning model. What we have also done is we have also done some of the work with Amazon SageMaker. Amazon SageMaker is AWS managed machine learning ecosystem services, if you will, that lets you create, build, train models. So, you can build cohorts in Healthe DataLab using EMR and the ontologies and the concepts that Cole was talking about. And then once you have your final data set created, you can use Amazon SageMaker for further analysis if there's a need for that. Next slide, please. So security is job zero. Cerner, AWS, that's our top priority. It comes before anything else. And we always make sure that the data is fully secured. Security has physical network system people process, which is validated and driven by customer security experts. In this case, Cerner. All the data sitting in S3 is fully encrypted. The data lake that is fully encrypted. The data access, user access is well defined, and it goes through a DevOps, SecDevOps process, which is security is part of the DevOps. So all the the rights and the usage is fully governed and managed well. Next slide, please. And finally, you know, this is a model of shared responsibility. This is how Cerner and AWS work together. So AWS is responsible for security of the cloud, so software, compute, storage, database, networking. Cerner is, you know, has well-defined security architecture that lets user kind of accesses Healthe DataLab through a well-defined roles, through a well-defined tokens that they leverage. And of course, you know, Cerner makes sure that they leverage each and every AWS features out there to control the user's access, audit every single thing, build alarms for security, and of course, integrate the data in transit and in store. So that's how, you know, AWS and Cerner are working together to create this platform, which will help enable data scientists to leverage the platform of AWS and the intelligence which is there in this application. Thank you.
Great, thank you. Dr. Feaster?
Dr. Feaster, are you unmuted? Dr. Feaster, are you you're not unmute, you're still, let's see, I've unmuted you.
To switch to computer audio.
Now we hear you. Okay.
Oh, okay. Oh, can you hear us now?
Yes, we can hear you now.
Okay. A little technical problem here. My phone decided not to unmute, I guess. Okay. My name is Bill Feaster. I'm the Chief Health Information Officer here at Children's Hospital Orange County. And I'm going to change the level of discussion just a bit with this presentation. Can I have the next slide? What we're going to try to cover today is to explore some of the scope and challenges of actually utilizing healthcare data and explain how we've applied advanced analytics and data science to predict readmissions as one of the models that we're working on. We're going to describe what we did before on our on-premise model and then what we're doing now in our cloud-based computational environment in Healthe DataLab. And how we've actually moved this back to the EMR and impacted the process of care. Next slide, please. Now, I'm not a data scientist. I have next to me Louis Acuermueza, who's our data scientist. When I talk about EMRs, I think about electronic medical records rather than elastic MapReduce. So as a clinical informaticist who's trying to, and clinician who's trying to figure out this whole field of data science, it's been quite an exciting journey, but certainly isn't my core competency. So Louis will answer any questions that kind of migrate into the realm of data science. Next slide. So as was kind of alluded to in Navneet's talk, there's a lot of data out there that we have to work with. We're awash in data. Next slide. Now, there's data from the EMR, and a lot of that data is readily available for patients at the point of care and available to us for analytics. The bad news is that a lot of the data in the EMR is really not available to us for analytic purposes, because 40% of it's in notes. A lot of it is in images like radiology, CT, MRI, ultrasound. Lab data may be in our EMR, but it might be also in outside sources. We have omics of various types like genomics and other things, streaming data, finance data, billing data, et cetera. So we have just a treasure trove of data, but trying to put this all together and integrate it so that we can take relevant facts out of our stores is quite a challenge. Next slide. So you've got all this data there, and we're trying to leverage, and have in fact leveraged, what we would refer to as predictive analytics, which is an arm of data science, which aims to take advantage of this data. It takes into account all available data on all qualifying patients, which is really great. And it explores the associations and statistical interactions between those variables. It uses a data-driven and statistically sound approach to determine the most important set of variables that impact care for that event of interest. What's particularly interesting is that human beings are really good at making decisions with just a few pieces of data, maybe 5 or 6. They're also very poor at figuring out what's not relevant to a decision. But we use statistics and take that into account in determining those variables that are important to include in a project. And we can predict the future occurrence of an event or classify patients at high risk of poor outcomes as well as other things. And then ultimately, our goal is to guide caregivers and help them intervene on patients identified to be at high risk and to lead to better quality and outcomes. So that's really why we're doing all this. Next slide. So this is kind of a summary of data science as kind of the merge of the statistical scientific methods that we're all fairly familiar with, along with data analysis models, along with the algorithms that are part of things like the SPARK machine learning libraries and stuff that's in our Amazon environment and in other tools like R. Next slide. So I want to start out by kind of what it took before we got Healthe DataLab available to us. We worked in our on-premise environment, and we actually made good progress. We did quite a few projects, both on patient satisfaction as well as readmissions, and published several papers from that environment. And so this is kind of the flow of what happens. First of all, you get an idea. This is what the subject that we're going to look into. That idea can come from others, can come from us. And the first step is to see what data you need. Well, sometimes that's a challenge. You have to go out and identify the sources of that data. You have to extract that data with things like SQL or out of Cerner, CCL, load that data into a secondary database. And then once it's in that secondary database, you run an analysis. In our case, we generally would use R. And we'd assess how well the model predicted an outcome, which is assessing the area under the curve. But invariably, you need better performance. So you have to repeat that cycle, go out, identify additional data elements, extract those elements, load it into the secondary database, often changing that database architecture to accommodate that data, running the analysis again, et cetera. And just running an analysis in our own environment would sometimes take weeks to go through a full run of all the data for a question. And then, but once you have the performance you want, you could implement that back into your electronic health record. A project from start to finish in this environment, maybe 6 months or so, just because of all those steps and delays in obtaining data or doing analysis. Next slide. But you can actually do good work in that environment, and I want to talk to you a little bit about how we applied data science in that environment to predict readmissions. Next slide. So this was the problem that was presented to us. We have participated in lots of national quality initiatives, and we pride ourselves as being one of the best. No matter what it is that we measure, we want to be the best. And there was one problem, which was 7-day readmissions, where we really, despite every effort that we could make, really made no progress. We were still hovering just above a national average of about 4% of our patients requiring readmission within 7 days. And starting back in 2013 up through 2017, did a whole bunch of stuff that was best practice to improve that. So we decided to work with our quality department and see if we couldn't apply machine learning as a way of reducing 7-day readmissions. Next slide. So this is our goal from our original model. It's actually a 30-day model because it turns out that our 30-day model predicted 7-day readmissions better than our 7-day readmission model. So this is the 30-day model. We started out with about 47,000 patients, and after some exclusions, ended up with about 38,000 in our study. Next slide. So we added some novel variables. We went back and looked at the literature and included all the usual suspects for data elements, but included also a severity tool called the Rothman Index. And quite amazingly, the other published studies didn't include whether or not the current admission was a readmission or how many times the patient had been readmitted before. It also, we added in medication classes. Next slide. And when we ran this model, we developed one of the industry best predictive models for 30-day readmissions with an AUC of about 0.79. Now, anything around 0.8 is excellent. 0.7 to 0.8 is pretty darn good, and anything less than 0.7, 0.6 is not very predictive. And we created 3 levels: high risk, medium risk, and low risk. And for high risk group, we predicted their probability of readmission within 30 days was 0.22 or 22% chance that they'd be readmitted within 7 days, and proportionally less for medium and low risk. We chose these levels because we didn't want to overburden people by predicting people by too many false positives. And when we actually, the next slide shows what we actually came up with. When we identified a patient at high risk, 52% of them were actually readmitted within 30 days. Medium risk, 26%, low risk, 5%. So we were pretty comfortable with those particular risk categories. We initially published the model with a spreadsheet and started using it that way, and then subsequently implemented, which I'll show you in our EMR. Next slide. Exploring the data with Healthe DataLab was a whole new animal. It made doing these types of things much quicker and also allowed us to consider many, many more variables and improve the models we were developing. Next slide. So if we sat down and said, what would our ideal data science environment to be as opposed to the one we were using previously, is an environment that is not limited by access to data. So all the data is there, it's available, you can put as much data as you want in it. Check, Healthe DataLab meets that. But the data elements needed for analysis would be easy to identify, and the mapping of a lot of our core data elements via FHIR data standards into our S3 bucket of Amazon really satisfied that need. We would not have to spend an extended time pre-processing this data. Well, the tools that are available within Healthe DataLab helps with pre-processing data. We would not be limited by computational resources, i.e. elastic map reduce, not electronic medical record, allows us to really assign however much processing power we need to a project. And we would have access to all available big data analysis tools, and this becomes very important as we start loading images, start doing natural language processing on large amounts of text and other things. So we felt that suddenly our ideal environment became available to us with Healthe DataLab. Next slide. And I think we'll just do the next slide, please. So our data from our EHR and other data sources in Healthe Intent. We had lots of claims data, pharmacy data, other things. Other EMR data is in Healthe Intent, is in Healthe DataLab in the S3 bucket. We have also Cerner's HealthFacts database, real-world data database, which has 68 million patients worth of data. It was something before that we had access to, but there's no way on-premise we could deal with files that were that large. We also have been able to upload things like the MIMIC3 ICU database sponsored out of MIT that lets us do other types of analysis on de-identified data. So we have de-identified data sources as well as identified data sources in our Healthe DataLab. Next slide. So this is what's changed now. If we have that same idea, same good idea of a project like preventing readmissions, first step is, do you have access to the environment? So as Navneet mentioned, there's lots of access controls and security around this. Then the data is within this environment, and there's even controls about what portions of the data in that environment you can access depending on your privileges. You retrieve that data with these big data tools, you pre-process it, you apply the various tools within the Jupyter notebooks, PySpark, the machine learning library, you run it fairly quickly, you get an AUC, and you may need still to go back, add new data to your problem, and then eventually implement your algorithm in the EHR. So all that is dramatically easier and much shorter timeline. As I'm sitting here, Louis is sitting next to me programming like crazy in a Jupyter notebook, trying to, and listening to me blather on. So let's go to the next slide. So what we did then is apply this new environment back to readmissions. First thing we wanted to do, since we were development partner with Cerner on this, was to validate that in fact we got the same results using the same algorithms on the same data. And so we validated the environment and got the same 0.79 AUC for the prior conditions. We then decided, what if we exposed our model to more data elements? How much better could we make it? And then we did some other things, including running a multi-center model for predicting general all-cause 30-day readmissions, because we took a subset of that de-identified HealthFacts database, identified 1.4 million children at 48 hospitals that had a predominance of pediatric patients over a 10-year period. And I'll show you the results of that in just a minute. Next slide. This is our newer AUCs. The model we actually are implemented now is model M1, which is applying more data to our environment. And we have an AUC now of about 0.82 in our current model being built into our system. We were able to improve this by changing the types of models we were running, the types of algorithms, et cetera. Next slide. What I find particularly interesting, though, is that as we applied this data, the same algorithms to data from other hospitals, it brings up the point that I think is really critical in applying machine learning, artificial intelligence to healthcare, in that there's a lot of data bias that occurs within. If you were to develop a model on an individual organization, then try to translate that model to another organization, you may find that there's quite a bit of difference in terms of the AUC from that model. For example, in our random forest model, when we applied this to those other pediatric, 1.4 million pediatric patients, we saw certain hospitals with as low AUC of 0.5, which is basically not helpful, up to 0.9, and saw the distribution of those different, whether you used a random forest or a multi-layer Percepton model. So the model that you use has different distribution as well as the patient population. So what we learned from that, and that's still pending publication right now, is that if you have an algorithm that's been developed on one hospital's data, you really have to develop the algorithm or refine that algorithm on the data from the hospital that you're going to implement a tool in. And next slide. Now, so we're putting this actually in our EMR. Next slide, and I'll show you how we've integrated this in the EMR. I think there's a build here, so click it next. We have the Cerner Millennium database. That data is pulled out to our EDW. We then run on our on-premise server through R, and we port that back into Cerner. Next slide. And this is just an example of how it appears in our EMR in a summary sheet. If you, we have a readmission is a little box on our patient summary. Up above, if you hover on that, it tells you what the risk score actually was and what is likely the reasons that that patient had a higher risk for readmission. So I think that's it for my part of it, and I'll turn it over. We are doing more things. We have published another model. This is our 7-day model, just appeared in Hospital Pediatrics, January 2020.
Very good. Thank you, Dr. Feaster. Janos, you're up.
Hello?
There we go. We hear you.
Okay, that's good. That's always the first step. Next slide, I guess, to... Hi, I'm Janos Hajagos. I am the Chief of Data Analytics at Stony Brook Medicine, and I'm also a Research Assistant Professor in Department of Biomedical Informatics at Stony Brook. Next slide. So a lot of people don't know where Stony Brook is. They kind of know it's in New York, where it's around in New York. It's out on Long Island. We're an academic medical center, 600-bed hospital. We also have 2 community hospitals on the eastern end of Long Island, the North and South Fork. We're a research campus of the State University of New York, and we have a Department of Biomedical Informatics, which is a joint department across the School of Engineering and the School of Medicine. And we also have a graduate program, master's and a Ph.D. graduate program. Next slide. So in about 2013, Stony Brook, part of New York, there was a Medicaid redesign program that occurred, and the group that I was with, we started working on how do we analyze this data across multiple healthcare systems. And this is showing you some of the challenges of that. If you look at diabetic patients, these are Medicaid diabetic patients, and those are the providers and the dots. It's a pretty complicated network or locations of different providers and the geographic restrictions. So this was an area sort of like we have multiple sources of data that we need to combine together into a single system. Thankfully, we at that time we were one of the early engagers with Healthe Intent. And Cerner, we worked with Cerner to sort of integrate all the different data sources into a single database called Healthe Intent. Next slide. So in this initial effort that we did, we had a very short timeline, and we had to move a lot of data across different systems. And I think now if we did the same project today, 4 or 5 years later, I think we have the environment of HealtheDataLab. a lot of things would have been streamlined and we could move faster. So as a data analyst, I spend a lot of time copying files, moving files, staging them, loading through a database, and that all takes time, and that keeps you away from analyzing the data. And we also might want to include public sources like ACS or the MPI database. And so we need tools to basically query, combine data from multiple data sources, and we also need to efficiently query large volumes of data. In general, when you look at healthcare data, when you start going into things like lab results, the data volumes just blow up. I mean, especially when you look at inpatient side. So you need tools that can query and scale to these large volumes of data. We also want to be able to apply, the leading cutting-edge algorithms, whether it's a TensorFlow, Keras model. So we want to be able to do that. Next slide. So as an educator, I teach classes on data analytics. Nowadays, most sort of people coming into our graduate program learn Jupyter Notebooks. It's a widely used tool. It's sort of becoming like the interface for analytics. You have the Jupyter Notebook. People can go in there. They can start working on the data, processing the data. I think that's always, in healthcare data, I think always the best thing is get people working on the data as close as possible to the data, right? And I think that's a great aspect of Healthe DataLab is you have this Jupyter Notebook. People can get right into the data, and they can start understanding the complexity of healthcare data. If anybody that's worked with healthcare data, the level of complexity, it just sometimes it blows your mind. I mean, just how to navigate and wrangle that data is always a challenge. But that's why it's best to kind of get people exposed to the data as early as possible. Next slide. We went a little bit over Apache SPARK, but Apache SPARK is a technology that's the main query technology that we use in Healthe DataLab to query data. If you have data analysts that are familiar with SQL, there's Apache SPARK SQL. So I can write my SQL, take my SQL, I can write it in this environment, execute it. Other great things in the SPARK environment, you can throw a random data set, for example, a compressed CSV file into a S3 bucket, and then you can query it as if it was loaded into the database. So it makes data integration relatively easy, and you can kind of experiment with that pretty quick. So that's one I think, that's something I really liked about Apache SPARK is that you can connect data sources a lot quicker. Next slide. So this just gives an overview of the current platform of the Healthe Intent platform and how Healthe DataLab sits within that platform. The Healthe Intent platform takes data from multiple electronic health records. Could be not just Cerner's, Epic, right? Could be all registries, also from claims. Integrates that into a single environment, aligns the codes to a single ontology, and then makes that data available. A lot of people that are Healthe Intent customers use the Vertica database, which exposes that database for analytics, and they build Tableau dashboards off of that. That's a very SQL-based environment. Healthe DataLab, now we can move into a more data processing environment, where then we can have our Jupyter notebooks, we can import our Python libraries that we need, and we can sort of execute and work on the data. We also have the ability to move back from Healthe DataLab into the Vertica environment, so any results we compute can then be exposed through a Tableau dashboard. Next slide. So as an example, this is one of the pilot projects we did. So we're sort of getting up to speed with Healthe Intent. We looked at the hemoglobin A1C registry measurement prediction. If you look at the AUCs in this case, we didn't get as high in this task as in terms of the readmission models, but this was sort of a pilot project to see how we could, just working within the Healthe DataLab environment, build a model and test it out. And we can also use things like scikit-learn, which is sort of like the standard library, the best supported library for machine learning models. And then once we build the model, it's very easy in this environment to apply the model to a population to get sort of risk profiles. And you saw the same sort of slide in the CHOC presentation. Next slide. Okay, so that was our pilot project, and so we're going head forward into a lot of other projects using the Healthe DataLab environment. We're working on a risk model for inpatient diabetics, and here's another example where this sort of like new data environment works well. A graduate student, a Ph.D. student, had developed an algorithm for looking at paired measurements of blood glucose and whether the interval was too long or not. And it was a pretty complicated algorithm written in Python. We were able to quickly take that Python code and execute it in the Spark environment against the data, and it had to do very little changes to do that. It might not be the most efficient way, but for the volumes of data we were able to get it done. Another project that we're working on is aortic aneurysm screening, and right now we're sort of defining the at-risk population, smokers, hypertension, certain age, and we're working with Cerner to extract the radiology notes and make those accessible within the Healthe DataLab environment. We're also developing models, predictive models for coded diagnoses for CDI, and we're doing data normalization in this environment. And we're also excited about the Cerner real-world data. We have the health facts data here on a Vertica cluster, which is a big job to maintain. And so once the Cerner real-world data is up, we're going to be able to directly query it from our Healthe DataLab environment. And that's what I had, a quick kind of overview of where we are at Stony Brook using this environment. Thank you.
Thank you so much. Wow, that was quite a presentation, and a lot of language in there that was definitely new to me. So we've got several questions. We can start off with what feature does, and this is for the AWS team, what feature does AWS provide that helps secure PHI that's typical within healthcare entities? Logically, these data sets need higher safeguards that go above what's used with other types of data sets.
Yeah, this is Navneet. So AWS works with a shared responsibility model. So we do have a whole set of features all the way from encryptions to security through tokens, SAML, services like Cognito, services like IAM to better have you define roles and policies. So there's a whole set of options and features you have. At a very high level, if you're storing your data in an S3 bucket, something similar to what we do at Healthe DataLab, you are basically applying a set of policy, who has access, who does not have access. You will be specifying the encryption option and where you want to store your keys. You want to specify the user access. So those are 3 or 4 levels of security you need to look at. And the features that I've just listed out, you can start with those. But like I said, it's a sort of a shared responsibility model where AWS and you and Cerner will work together to make sure your data is secure and accessible.
Okay. Okay, thank you very much. So I'm not sure, and Cole, maybe you can help direct this question. The question is, have you looked at if the same patient came back after, I guess this is Dr. Feaster, came back after the 30-day window, are you treating her as an index?
In looking at Louis next door, he's shaking his head yes. Did you want to?
So basically the idea is we can see patterns across time rather than, there are several ways you can model a readmissions. You could build a readmissions model. And one of the statistical decisions is, do you want a single patient regardless of how many times they've been to the hospital, or do you want to take into account multiple index visits while controlling for correlations between patients or clusters of patients or using longitudinal data analysis approaches. So we did include multiple indexes, and in our models, we controlled for any correlation that will be induced by that.
So now you know why I brought Louis with me.
I would need Louis, beside me too for this topic. Another question is, can researchers outside Cerner get access to this data lake?
Maybe you turn that to Cole.
And what was that question? I'm sorry.
Cole, can researchers outside Cerner get access to this data? Is this data lake?
I think it's probably referring to the Health Facts database, the real-world database.
Yes, there are the Cerner real-world data set. You can get access to it, but it stays inside the Cerner ecosystem exclusively. But if you would like to get access, feel free to reach out. And I believe we'll send out my email address and we can talk about how that's done.
Terrific.
And
another question is,
partner organizations, we can, for example, that we have access, we can team up with our university colleagues who may not be on Cerner or have direct access to Cerner, but there are rules for how they can access the data and how we work together on doing projects. So it is available, but there's a little complexity associated with it.
Correct.
Thank you. So another question is, I'm wondering what kind of NLP analysis you're doing. Are you looking at social determinants of health issues that impact your readmission? And if yes, what type of analysis are you doing with this data?
Well,
so Dr. Schuster and Janos, both of you. I'm sorry.
Yeah, well, I'll quickly say we are just now implementing some of our NLP tools and looking at that. We do have access to demographic and some fairly rudimentary social determinant data that is built into the models, such as geography and others. So that's about the extent that we're doing it currently, but maybe Janos has a better answer.
In terms of social determinants of health, the Healthe Intent pipeline does a pretty good job mapping, for example, questionnaire answers like smoking for PHQ-9s. So there's a bunch of discrete elements that sort of maybe not traditional EHR lab results that can be processed. In terms of documents, working with Cerner to bring those into the environment so that we can query those directly.
Thank you. I think we have time for one more question. Which methods are being used to check for duplicative patients, deduping identified and de-identified patients? So Dr. Pfister, maybe we can start with you.
Well, we leverage the Healthe Intent environment, which is what's loaded, the predominant data source that's loaded into our data lab environment. And Healthe Intent has a fairly sophisticated pre-processing of data such that data is cleansed and normalized and goes through a master patient indexing process such that it creates a unique patient record. So leveraging the tools within Healthe Intent allows us to do that. Cole, do you have anything more you want to add to that?
Nope, that's correct. There's a host of data services that are facilitated by Healthe Intent, and that's what our users typically leverage, or they go after some more granular raw data sets.
Janos,
for example, the raw data that we've added into the environment is not identified data. it's separate data sets, so it would not interfere with any of the current identified data that we have in that environment.
Correct.
Any other points to be made about that question? Okay, so finally, for the readmission study, what types of interventions did your predictions inform, and lessons learned getting prediction process into a production practice?
Okay, I didn't go into a lot of what the people actually are doing. The good news is the outcome is we're actually reducing readmissions. But we're not telling people what to do. We're informing them about which patients they should spend more attention on. For example, when we first implemented it, they were focusing on the high-risk patients, and they very quickly realized that there's a high-risk patient you probably can't do much about. They have clinical conditions like cancer or other things which lead to frequent readmissions, and so there isn't much intervention is going to change in those patients. So instead, they focused on the moderate group of patients with a probability between, 0.11 to 0.22 by our definition. And those are patients in which interventions are starting to make a difference. And nothing is clean. We have a lot of different approaches, from education on medications to calls to parents to the things that care managers normally do to try to prevent readmissions that they were doing anyway. They just have a new group that they can really focus their attention on. And they have made progress. But we don't prescribe an intervention to them. We just inform them on who is at risk.
Well, okay. Well, I think that that last comment concludes the webinar for today. I want to thank our amazing presenters, really explaining information in a way that even I can understand. It's very complex information. It's really fabulous, progress in artificial intelligence and machine learning. So I also want to thank the participants of the webinar, and we look forward to seeing you on the next webinar. Thanks so much, everyone.